today's class, we will talk about, first of all, capacitance. We will talk about capacitor. Okay, so today's class, first of all, we will talk about capacitor, and then we go to magnetism, and then finally to electromagnetic induction. So today's class we will cover these topics, and also we will do questions from past papers. In the previous class we were talking about capacitor. We just discussed a little bit about capacitor, so I will just write down the key points again here, and then we start from here. So first thing we discussed was capacitance. So the capacitance simply we can define like this. We can define capacitance straightforward, that C is equal to Q over V. For example, if we have a capacitor here and this capacitor is connected with power supply, and let's say we have one resistor here. So this is very simple RC circuit. So in this case, the capacitance means that the charge on this capacitor divided by the voltage across this one. So C is equal to Q over V. Often we remember this one, Q is equal to CV. And also we have discussed the unit of capacitance. The unit of capacitance is farad. So farad, and we use letter capital F for this one. And capacitance actually is not depending on Q and it's not depending on V. Actually, capacitance depends on epsilon naught A over D. A is the area of the plate. It depends on area of the plate. If the area is bigger, so capacitance is greater. So area of plate, it depends on, this is one thing, and also it depends on separation between plates. So it depends on separation between plate. So these few things, first of all, we need to understand. It depends on separation between plate. So you can see here from here, if D is greater, it means C has to be smaller. And also we have discussed about capacitors in series. So last time we were talking about capacitors in series. So we saw if we have capacitors attached like this, and let's say these capacitors are connected with a power supply, so like this. If the capacitance of this one is C1 and capacitance of this one is C2, and the total capacitance we saw in the previous class that will be equal to, so if two capacitor is a very straightforward, but this is a general formula for more than two capacitors. So we can use 1 over C1 plus 1 over C2. This is how we can calculate. So if only two capacitor, for example, so the simple way we can simply say that, so this is C total will be equal to C, this is we can find out, this is C1 C2 over C1 plus C2. So this is for two capacitors. This is only true for two capacitors. We can calculate like this. So this is for two capacitors only. So this is for two capacitors only. So we can remember like this. But if C1 is equal to C2, for example, then C total, for example, if we say we have 10 capacitors like this, for example, we have one capacitor, we have another capacitor, we have another capacitor, and so on. Let's say we have 4 capacitors now, and all of them, they are connected in series. So if we need to find the total capacitance, if they are identical capacitors, so let's say all of them, the capacitance is C, capacitance is C, capacitance is C. So for identical capacitor, this is a general formula, is a very important thing to understand, especially for physics board. So for identical capacitors, so if we have, for example, n number of capacitors, so simply you can divide C over n number of capacitor, n for number of capacitors. So if you have 4, n will be 4 and so on. N is number of capacitors. So this is what we need to understand. N is number of capacitors. So simply we can use this one. Okay, so this is how we can find if there is capacitors are connected in series. On other hand, we have also discussed in the previous class if capacitors are connected in parallel. So we discussed in previous class a little bit we discussed. So let me explain a little more about this. So if we have two capacitors like this, so if they are connected in parallel, so let's say we have a power supply here. So like this, we have power supply. Let's say this capacitor is C1 and the capacitance of this capacitor is C2. So the C total simply is equal to C1 plus C2. So just like resistors in series, so they are just opposite actually. Resistor in series, capacitors in parallel, and resistors in parallel, capacitors in series. So we can calculate. Okay, so in this case we need to understand what is same actually. So let me write down when the capacitors are connected in series, so what is same? So the same will be Q is the same. In this case you can see when capacitors are connected in parallel, so what is same in this case? So the same is voltage. So this is also important thing we have to be clear. So it has to be same. Okay, so these things we have discussed a little bit at the beginning or at the end of the last class. So now we also have again recap these things. So we have to be quite clear about these points. Okay, now let's go and try to explore more about capacitor. Actually, for physics bowl, we need to understand more than A2 level. So today's class, I will explain you that part you need. So let's go and try to explore that part. Okay, so here you can see here now. Look at this one. So you can see we have a power supply. So let me little move this one on one side. I will just place here for a while. So now you can see we have a battery here and we have a capacitor here. So I will connect this battery like this. Now we can see here the voltage across this battery. So you can see from here. So this is the voltage. So you can see voltage from here. You can read from here. So you can see this is the voltage on this battery, on this power supply. We can see here. This is the voltage, the same as on power supply. So this is equal to 1.285 volts. So this is what we can see now. Now the next step what I will do is I will keep connected battery. I will not disconnect battery. I will keep this battery connected. So I will say battery stay connected. So I will simply write down battery stay connected and I will pull these plates apart. Pull plates apart. So this is thing what we need to understand. Pull plates apart. So if I move these plates apart, then what will happen? Okay, so first of all, you can see here, then we will do with calculations. So you see here, this is connected. I will pull these plates apart. You need to understand here, you see, I pull these plates apart. You see, I bring them back and I pull them apart. So you need to observe this one, what is changing and what is not changing. So you see plates here, I bring them to this point. So let's say we check the voltage again. So you can see here, voltage stay same. So this is one observation. So we can write down here, if battery we keep connected and we pull these plates apart, what stayed same? So what stays same? Voltage stayed same. So we simply write down voltage will stay same. Okay. Now, how about the capacitance? Let's say the distance is double. Let's say we change this distance, the separation between plates, let's say from D to 2D. If the separation we increase, capacitance we understand that is equal to epsilon naught A over D. A over D. Now, if this number we increase, let's say if this become double, you will say this has to be half. So the capacitance decreases. In this case, capacitance will decrease. Now, how about Q now? So we can write down here then that the C nu will be equal to 1/2 of C naught. And V is the same, so we will simply say V nu is equal to V naught. Why? Because it is still connected with battery, so voltage will not change. Now, we also understand Q is equal to CV. Now, if you can see from here, if this become half, for example, and V stays same, how about Q? Q also become half. So we will say here the Q nu will be equal to Q naught by 2. Means half of the charge has been decreased. Okay, half of the charge has been decreased. So you can see here half of the charge went back. So let me show you this animation one time more so you can see the charge increase. I move apart, charge decrease. Why charge decreases? Because the capacitance of capacitor means the ability of capacitor to store charge, or we can say that ability to store energy has been decreased. So you see less charge, more charge, less, more. So this is very important. We need to understand. There can be a lot of questions about this. So this concept is very important. Okay. Now let me one thing more we need to understand. So this is another thing we need to understand. So that is about energy stored on capacitor. I didn't explain you this formula before. So let me just write down here for you. Energy stored in a capacitor. So energy stored in a capacitor. Energy stored in a capacitor. So here we can say energy stored in a capacitor. So energy stored in a capacitor, we can calculate that E is equal to 1/2 QV. We can also write down like this is equal to 1/2 CV square. C is the capacitance. We can also rearrange this formula by using Q is equal to CV. If we just little bit rearrange, we can write down this formula in terms of Q and C. So what we will get, that will be 1/2 Q square over C. Now, if we see here, over V is the same. V is the same, but the charge become half. So it means energy stored on capacitor will be half. If you keep this one connected with battery and you pull plates apart, if you double the distance, energy stored on capacitor will be half. So that you can see from here, with this formula you can see that if this become half, so the energy stored will be half. So this is Q by 2. So these are the points you have to keep in your mind. Okay, so what is happening if batteries stay connected and we pull these plates apart? So these are 4 points you have to understand. Okay, so this is one situation. So for taking notes, actually you can watch this video after class, or when you're watching this one you can just take screenshot, so that is enough. Okay, so let me explain you an other situation. So the next one is, okay, I will clean this one now. So I will explain you an other possible situation. So let me first clean this one. I will clean now. Now you can see here This time what we will do is we will disconnect battery. We will disconnect this one. Then we will study the same effect. Now I will disconnect. So you can see the voltage across this one is 1.285 now. Now I will disconnect this battery. Okay, so you can see here voltage at this time. At this time I have disconnected battery now, and then I will pull these plates apart. So I will pull these plates apart like this. Okay, now how about voltage? Maybe you will be surprised. You see this voltage has been increased. Okay, so let's try to understand what is happening in this case now. So what we did, battery disconnected. So we will write down here, we disconnected battery. So we will say battery disconnected. So this is what we can say, battery disconnected, and plates pull apart. So we will say plates, I will just simply say plates are pulled apart. So this is pulled apart. So this is now. So in this case, we need to understand what is same. The first thing we need to understand is that what is staying same. In this case, charge will stay same because charge has nowhere to go. So the charge will be same. So I will simply write down Q stays same. Now, how about capacitance now? So the capacitance as C naught, for example, is equal to epsilon naught A over D. But now if we need to calculate C nu, we can write down this is epsilon naught A. Area is not changing. Epsilon is a constant. And the distance is double, let's say 2 times. So this one has to be half. So what we will get, we will write here, this is C naught by 2. Means the capacitance of capacitor has been decreased to half now. Now, how about voltage? Let's say initial voltage, let's say this is equal to V naught, is equal to V naught. So how about V nu? So we knew, so we can write down little bit in a different way, so little bit in detail. So first of all, we have V naught, that was equal to Q over C naught. And so from here we can say, how about V nu? So we can write down V nu. The Q is the same, so we can simply say Q stays same, and capacitance become half. So this becomes C naught by 2. So we will get from here, this is 2Q over C. It means this is 2 times of V naught. So this is 2 times. Voltage has been increased. Voltage is double now, as you saw from this number. Why voltage has been double? Because when we pull these plates apart, we did work on the plates. When we did work on the plates, the work done by us is stored on capacitor in form of energy. So we did positive work in this case. So we will say V increased because positive work is done. So we will simply say positive work is done. So this is one thing you need to understand. So positive work is done. So that's reason voltage increased. So if we find E nu, for example, if we calculate E nu, we can also find out this is 1/2 Q, and the V nu, this is 2 times of V naught. So it means the energy nu is 2 times of initial energy stored on capacitor. So this is what we need to understand, and you have seen with animation as well. Okay, so this is okay. So these points we need to understand. Okay, so if this point is clear to you until now, if you are clear, if it is okay to you, I will go to next one. Okay, so I will also show you with animation, then I will explain to you what is happening. So let's try to understand the next step. Now you see here we have kind of insulating material here. This is kind of insulating material. So I can say this is insulating material. We have insulating material placed here. You see this a box of charges look like that it has same number of protons and same number of electrons. Insulating material, and this is what we call is dielectric. Dielectric mean it can be polarized, so we call this is dielectric. So what is the effect of dielectric on capacitance? Let's say if we have one capacitor, here we are talking about this capacitor now. So what is between these two plates? That is air actually. K for air is equal to 1. That's reason the formula we write here, you can see this formula here. So we call C is equal to epsilon naught A over D because K is equal to 1. So we simply write down this is epsilon naught A over D. But if this is other than air, value of K will be greater than 1. So it means the capacitance will increase. So we can also find out. Okay, so you can see here now. So if I move this one inside, I will first of all I have to connect this one. So now I connect this one. If I move this inside, you will see more charge on this one. Can you see? If I move out, less charge is stored. If I move inside, the ability of this capacitor to store charge, or we simply say storing energy ability, has been increased by inserting this dielectric. So you can see, if you look at this one, is also very clear to you. It should be very clear to you. You can see here. Let me write down here for you what is actually happening. You see the charges here now, but if I move this inside, can you see now positive and negative? Here it has been polarized actually. So here you see positive and negative. Let me redraw here for you what is happening. So let's say this overcapacitor, this side is positive and this side is negative. We can just draw like this. Let's say it is connected with power supply, so we can see like this. Now when we insert actually dielectric, so let's say we insert this dielectric inside, so this is insulating material. When we insert this inside, this material will be polarized. So what exactly it means? Just 1 minute, I will explain what does it mean. When we insert this one, so atoms inside this one, they will be polarized. So means this side is positive, so electrons will be attracted towards this one and positive charge will be on other side. So if I draw electric field now, so I will just use another color. So due to this one, electric field is like this. We can just draw a few lines. We can see here electric field is like this, but now if you see inside, it produces its own electric field in the opposite direction, so the net electric field will decrease. It means more charge can be stored. So in this case, net electric field decreases. So net electric field decreases, it means ability to store more charge will increase, or simply we can say that capacitance of capacitor will increase. So in this case, by inserting dielectric, we can increase capacitance. Why? Because this will be polarized and net electric field will decrease. You see one electric field is pointing to the right and the inside this one is pointing to the left, so they will cancel each other. Not 100% they will cancel, but electric field, net electric field will decrease. It depends on dielectric. Okay, so one thing we have seen from here, we can increase the capacitance of a capacitor by just inserting dielectric inside, means insulating material between plates. So we can increase capacitance. Okay, so this is one way we can increase capacitance. Okay, so let's go and see. There are still a lot of points we need to understand about capacitor. So I will go to next one. I will show you next, and then I will explain to you. So next, what we need to understand is, now look at this circuit now. So let me move this one here. So you can see this circuit now. If it is not okay, now you can see here. At here, let me redraw circuit for you. So what I have in this circuit, you can see here we have a battery. So we have one battery here. So this is battery. This side is positive and this side is negative. So we have one battery like this. Okay, so this one is a battery. And at this point we have one resistor. So I just draw resistor for you. So here we have one resistor. So I will just draw a small circuit for you to see what we have in this circuit. We have one resistor here. If we go here, we have one switch. So this one is a switch. And then we have one capacitor. So this is a capacitor. So we have one capacitor at this point. And here we connect, this circuit is complete. But we have the second part of the circuit as well. In the second part, you see, we just have wire. So I will simply say we have just wire. And after wire, we have one switch. You can see we have one switch here. And after switch, we have one light bulb attached like this. So we can complete this circuit. Okay. So this is what we have inside this circuit. Now, let me close this switch and see what is happening. First of all, I will close this switch actually. I want this to discharge first of all. You see, this capacitor is discharging now. It's discharging. You will see after a certain period of time, this bulb will stop glowing. Now you see, this capacitor has been discharged. Little bit charge is left, so we just wait and then okay, now I will open this switch again. And if you see here, for example, one thing you need to observe is that if you look at this curve, actually you see voltage decrease across capacitor. Now voltage is almost 0 here. So let's start from other end actually. So this we can open now. Now we close this switch. So what you need to do is, here are 2 points for you to observe actually. One thing is here. You have to observe here what is happening on this graph, you have to observe. And the second one, you have to look at this one. What is happening here? What is happening here? So, okay, let me close this switch now. I close this switch. Did you see what happened here? You see, first of all, current was very high. Then current start to decay. It start to decrease now. And if you look on this one, the voltage across capacitor at the beginning was 0. Then it goes to maximum value. And after that, it stay steady. It stay constant. So this is, you can see from here. Now you will see it will not change because now voltage across this one is equal to voltage across battery. So there are few points we need to understand. So let me write down here for you. So here are the points you have to understand. So later we will use these informations to answer some questions. I will say at time t is equal to 0. We need to understand at t is equal to 0. We will say the voltage across battery has to be equal to voltage across resistor. We have this resistor here, and it has to be equal to voltage across capacitor. So when T is equal to 0, VC at that point is equal to 0. So the voltage when T is equal to 0 means when you just close the switch, at that time voltage across resistor is equal to voltage across battery, and the capacitor at that time when you just close the switch. So I will write down for you. This is very important point to answer questions about RC circuit. Just close the switch. When you just close the switch. So this is point you need to understand. When you just close the switch, at that point capacitor is acting just like a wire. Capacitor acts like a wire, simply just like a wire. So this is you need to keep in mind when you just close the switch. Second thing you need to understand, at steady state, when the capacitor has reached steady state, means after long time, or you can say after long time. Another way to say, you will see now, if you see I, this is I now. So this is I, this is current. If you see here now, it has been quite long time. You see I is equal to 0. So what we will say from here, we will say the VB again has to be equal to VC. Again, it has to be equal to plus VR. But now as I is equal to 0, so it means that VR is equal to 0, and the VB in this case has to be equal to VC now. Okay, no current is flowing. So now your capacitor is acting like an open circuit. So the capacitor is acting like an open circuit. So we will simply say like an open circuit. So these 2 points are very useful to answer RC circuit. So what I'm saying is that RC circuit, so RC circuit means that in one circuit you have resistor and also we have capacitor. So that kind of circuit we call them RC circuit. So in one circuit we have capacitor and also we have resistor. So we call them RC circuits. So you can see here RC circuits. Okay, now, one thing more I want you to understand is that now if you look at this, let me clean this one, little bit messy, but before I clean this one, I want you to notice one point very carefully. Now if you look at this one now, is this line is horizontal or not? This line you can see here, if you look at this line, you will simply say, oh, it is horizontal. Why this line is horizontal? So you can see here, with time the voltage is not changing because voltage across this capacitor is now equal to voltage across this power supply. So the voltage is constant, it is just a horizontal line as you can see from here. So and I is equal to 0. So this is one thing about charging when we charge a capacitor. So next one, let's go and yes, this one actually we can find with that one. Later we will go to equations. We will go and I will explain to you how you can find these values. Okay, so later I will go, we can use calculus, we can find the equation. So we will go to that one after just few minutes. Okay. Okay, so next one please. So this is about charging now. We will go to those equations later. Okay, now let's try to understand about discharging now. So let me clean this one and show you what is happening when we discharge a capacitor. So now you see, I will open this switch now. You can see we will open this switch, and at this moment you can see the voltage is constant. It's not changing with time now, and this current is zero now. So now I will move this one to here, and now this switch you can see is open, means it is disconnected from this power supply, and I will close this switch now. So we close this now. You see the brightness. If you look at these two graphs now, so you need to understand what is happening to current actually. I is decaying with time. So you will say this is decaying. So it is decay graph. You can see here it is decay. And this is also, you can see from here, this is also decay. The voltage across capacitor is decreasing, and current in the circuit is also decreasing. How we can calculate at any given time, I will go and I will explain you how you can calculate if you need to calculate voltage at any given time. So I will explain in after this one. I will explain to you how to calculate. So this is the trend actually. At this moment you only need to pay attention to trend, what is happening here. Okay, so these are our observations now. Now we will go and we will study how to calculate. Okay, so this is okay. Next thing, how to calculate means in our exam. So that is our main goal actually, how to calculate. Okay, here please. Now you can see here. Okay, so here you can see from here. And so first of all, we are talking about charging a capacitor, as I showed you first of all when we are charging a capacitor. So this one we can find out by calculus. We can, in a circuit actually, first of all you can use Kirchhoff's second law, KVL we can use, and then we just differentiate and you will get the answer. Okay, we can prove this one with that, but we don't need here now. We just need to understand how to calculate the formula. So I will just talk about how to calculate. So but here you can see now this is VT. So this is telling you if you need to find voltage at any time, and this is the voltage of the battery. So this is the voltage of the battery, means this is voltage across battery. So this is voltage across battery. So simply this is voltage across battery, and E is a constant, and T is time. T is simply is time. R is the resistance of the circuit. So R is the resistance of the circuit. As you saw before, we have a resistor here, and then I attach one capacitor here. So this was power supply. So let's say this was a power supply, and this one is over capacitor. This one is over capacitor. So R mean the resistance of this resistor, and C mean capacitance of this capacitor. Okay, so C is the capacitance. So when the capacitor is charging, and if you need to find the voltage at any given time, we can use this one and we can find it. Okay, so this is how to calculate. On the second thing, if you look at this one now, the current across capacitor means in the circuit, it means current in the circuit at the beginning will be maximum, but as time will pass, current in the circuit will start decay, means start to decrease. So you can see it start to decrease. So how we can calculate I at any given time? So here this is how we can calculate. So I naught means that you can say maximum. This is I max, means at the beginning the maximum current. So this is E, again e to the power of minus t over RC. So again we can use this one and we can find current in the circuit at any given time. Okay, we can calculate with this one. But here are few points you need to understand. They are very important points. Now you see here this RC actually. This is something very important you need to understand. Okay, RC actually the product of resistance and capacitance. We call this is time constant. So this is time constant. So this is called time constant as it is a time actually. So what is its unit? You can try by yourself if you have resistance and capacitance. If we solve this one, because it is a time, unit we will get is second. So the unit of product of RC, that is called time constant. The unit is second. And often we use for this one letter tau. So this is tau. So this is used for time constant. So what this time constant tells us, as we have studied about half-life, we said the half-life we have discussed at IGCSE level. Half-life simply tells us a certain average time taken for half of the atoms to decay. Means in that given time, if we have 100 atoms, for example, if I have 100 atoms of X element in one half-life, what will happen is that 50 atoms, they will decay into an other type of atoms. Means this X will be 50 remaining and 50 will change into an other atoms, mean nuclei. So this time taken, fixed time taken, in which half will decay and this process continue. So in this case, what is a time constant is telling us? Time constant is telling us is that in one time constant, if you see from here, maybe here, if you see here in one time constant, you can see from here, it will charge to 63.2% of final value. 63.2% of final value. And in next time constant, again here in next time constant, again it will charge 63.2% of the remaining. So again and again in next one, again it will continue this one. Every time it will charge 63.2% of remaining value. So you see after 5 tau, after 5 tau is a very important number. So let me ask you one question now. If I give you this formula, and if I ask you how long this capacitor will take to discharge completely. So how long this will take time to discharge completely, how long this capacitor will take. Time taken to discharge completely, or we can simply say discharge, or we can say discharge, fully discharged. So this is discharge fully. How long it will take? So how long it will take to discharge fully? Means in this case we're talking about infinite. Excellent. It will take infinite. Discharge fully or charge fully. So if I ask you an other way, so just 1 minute. So if I ask you in a different way, if I also ask you this is discharge, and charge also is true for both. So if I ask you to charge fully, so it also is true. Actually, this formula is for charging. Actually, charge fully, it will take infinite. This is theoretically. Theoretically, we will say in this case, as you can plug in number in this one, so you will find theoretically time taken should be infinite. But how about practically? So practically, how long this will take to charge fully? Practically, when we count that time, we took that time equal to 5 RC, and R we simply say is equal to 5 times of time constant, or we simply say 5 tau. Okay, so at this point, if you look at this number now, so this is after 5 tau, 99.3% it will charge after 5 tau. So for practical purposes, we take 5 RC. Okay, so this is one important thing you need to understand. Okay, practically 5 RC, but theoretically is infinite. Okay, so this is we need to understand. Now please, is this one is okay? So then we can move on to discharging. Okay, so this formula you need to understand. We will not go to prove here because we don't need, but if you're curious later, I will prove for you as well. It is not a big deal. So you just need to understand how to use them here. Okay, just have a look at this one. If it is clear to you, I will go to discharging now. The next. Okay. Okay, let's go to next one now. Try to understand next about discharging now. Okay, so here, for example, I also have drawn this table for you to so you can see it in a better way. So if you look here, you see after 1 tau, 1 RC, it will charge to this much. Second, after third, 4, after 5, it will charge to 99.3%. So we say it is fully charged. So that's the reason we say it is fully charged after 5 tau. But here is a one number that is very important. So I also want you to understand this number. So you see here, after time, 0.7 RC. If you wanna understand in a little clear way, or you wanna get the more accurate value, that is actually 0.693 RC. After this period of time, this capacitor will actually charge about 50%. 50%. So this number 0.693, we call this one half-life of capacitor. So this one what we call is half-life of a capacitor. Half-life of a capacitor. So half-life of a capacitor is equal to 0.693 RC, or you can say 0.693 tau. If I ask you how long capacitor will take to charge 50% of final value, so you just need to use this one. That's all. So this will give you the time. So this is called half-life of capacitor. It is possible in exam there will be some question about half-life of capacitor, and this one we can find out. For example, with this one or with discharging, we can just find out just very simple one. So you can find out when become half and you can solve, you will get the value, this number you will get. Okay, so here for example, if you want to find from here, so this is I naught e to the power of minus t over rc. When this become half of this one, when this become I naught by 2 and this is I naught, and then you can solve and you will get value of t. So I cancel, this is 1 by 2, and then you can solve and you will get t is equal to 0.693 rc. Okay, you just need to take L natural log on both sides, that's all. So this is half-life. We need to keep in our mind what is half-life of capacitor. Okay, so let's go to next one. Little bit discuss about discharging. So here you can see discharging. Now you see all these graphs, they are similar. It means when capacitor is discharging, for example, we have a capacitor here, and let's say this capacitor is fully charged. I will say at this moment this capacitor is fully charged, and we have one switch here, and here we have light bulb, or we have a resistor, and this one, let's say, is fully charged. So this capacitor is fully charged. As long as here, as soon as you will close this switch, this capacitor will start discharging. So we will say the voltage across the capacitor will go down, and current in the circuit will also go down, and the charge on capacitor will also go down. So that's reason you see here we have for voltage. So the VC at any time, for example, when you need to find when your capacitor is discharging, so it has to be decay graph actually, V naught e to the power of minus t over RC. Okay, this decay graph means you will get this decay curve actually, decay. And also if I ask you what is formula for I, how to calculate, I is also has to be same, I naught mean I maximum e to the power of minus t over RC, and this RC is time constant. This is time constant, so this is I at any given time. So at any given time, so I will write down this is at any given time. So if you want to find at any specific time a value of I in the circuit, you can find with this one, and this one is the I maximum, so you can find maximum. Okay, so this is, so here is a Q actually. So if you need to find the Q on the capacitor, means how much charge is left on the capacitor at any given time. So again you can find out this is Q final, or you can say this is Q initial, or you can say this is Q maximum e to the power of minus t over RC. Yeah. You see all three formulae are same, because decay charge is decreasing, voltage is decreasing, and current is also decreasing. So this is how we can figure out. Okay. Okay, so let's go and do some questions now first. So let me stop this one here. I hope these things are clear to you, and at least you have some understanding of these things now. So let's go and try to answer some questions and use this knowledge what we have covered until now. Let's move on to next one. Okay, here please. I will also guide you if you are not clear about any point. So now try to answer these questions now. Okay, please, you can type your answer. First read question. If you need some help, just let me know. Okay, excellent. So it has to be E actually. So you see in this case, potential difference, the battery is disconnected. So if you pull the plates apart, you will do positive work and the energy stored on the capacitor will increase. It means the voltage will increase because Q will stay same. So this is what is happening. That's excellent. So this is what is happening. Let me redraw for you. So some of you may be not clear. So what will happen is that what we did now, we did like this. Now we pull apart these plates and we disconnect battery. So this one was D. This is D and here is 2D now. So in this case, as the battery is disconnected, charge has nowhere to go. Charge cannot leave. So it means charge stay same. And then you can figure out. Okay, excellent. Answer is E. Wonderful. Okay, electric field, for example, this is actually depends on charge density. So this is charge density over epsilon naught. So this is equal to Q over A time epsilon naught. Here, please. Okay, here. So this is how you can find. Okay, so this determine electric field intensity. Okay, so this is how we can figure out. Okay, so in this case, charge stays same here. Okay, this is same. So electric field here, this is same, but you increase the distance. So then you can find out E is also equal to delta V over D. So E stays same. If this is double, this also has to be double. So this also you can understand. Okay, so uniform you can also understand with this formula. So this is an easy way. Okay, so let's move on to next one. Okay, so this is answer. Okay, so let's try this one now. Okay, so please try this one first by yourself. I'm drawing for you so you can see what is happening. Okay, please, here I have written for you to help you a little bit. So so now tell me what is your answer. Yes, it should be A because you can see here the work done in this case is equal to Q times delta V. So F is given, D is given, Q you need to find, delta V is also given. Just rearrange this one and plug in numbers and you will get your answer. So hopefully this is the right answer. So if you got this answer, that's wonderful. So this is how we can answer the work done is equal to Q times delta V. Electric force, because electric force is doing work in this case now. That work is equal to Q times delta V, electrical potential energy. Okay, so answer is A. Now here please, now try this one now. Okay, so this is something you need to understand is that voltage across battery at any moment has to be equal to VC plus VR by Kirchhoff's second law by KVL. Delta V has to be equal to 0. Okay, now if you solve you will get your answer. I think answer is right, is D. So this is, please, you need to understand, at any time KVL has to be true, delta V has to be 0. It means VB has to be equal to VC plus VR. VB means the voltage across battery. So then you can find out this is 12, and VC you need to find, and VR I is given to you, and R is also given at that given time, and you will work out, and VC in this case you will get is 7. So this is 7 volt. Excellent. So 7 volts you will get. Okay, excellent. Answer is D. How about this one? Little bit challenging, but you have to be very clear about this. So try this one now. Okay, please try this one. Okay, let me help you a little bit. So here I wrote some points for you to understand. So this is immediately after. It means at time t is equal to 0. So simply we can say at t is equal to 0. So your capacitor will act like a wire. Just listen now. If you have done, is wonderful. If you didn't finish until now, no problem. Let's try to discuss and try to figure out the right answer. So it means that it will act like a wire. So simply we can say that it's just like a wire. So this is just like a wire. So simply you can say it is like a wire. If this is a wire, for example, so we see the potential at this point is a wire. So there is no potential difference in an ideal wire. So there is no delta V. It means that if I say this is point 1, this is point 2, it means the V1 has to be equal to V2. So I will say at this point is V1, let's say at this point potential is V2. Because this is just simple a wire, it means the potential here has to be equal to here. So let me clean this part. It means V1 has to be equal to V2. So the V1 has to be equal to V2. Okay, so V1 has to be equal to V2. So the first thing we need to understand is that the voltage across this one means the voltage drop across this resistor has to be equal to voltage drop across this one. Same voltage drop here, same voltage drop here. So that's reason, then it is possible that V1 will be equal to V2. So how we can find out how much voltage is dropped? So for that purpose, you need to understand, if I have these two actually, can we draw like this? So you see, voltage across this one is equal to voltage across this. Can we say these two resistors, they are connected in parallel? So another way to draw is, I can draw like this. This is just a wire. I can just draw like this. Okay, so these two are in parallel. Then again, these two, voltage across this one will be equal to voltage across this one. They are also connected in parallel. So you see these two are connected in parallel and these two also connected in parallel. But this one is in series with this one. So then you can also connect like this, or you can understand like this. So it is up to you. Otherwise you can understand from the figure, but this is one way to draw. You can understand like this. Now we need to find the total resistance. What is R total? So we need to find R total. So you see these two resistors are in parallel. So you can find the total resistance. So that one will be 400 times 100 divided by 500. Then they are in series. We can find total resistance of this. So this is 300 times 200 divided by 500. So then you can solve this one. If you solve, you will get, this is a 200 ohms. So we have find R total. So this one, please look at this. So we can find R total now. Now, the next thing we need to find out is what is the total current in the circuit. So if you have this resistance and this is our power supply, we can find out I total. So that will be 12 divided by, this is 200. So we can divide by this and then we can find out total current we can find out. So this will be 6 and this will be 100. So we will get, I think, 60 milliamps. Okay, so this is how you can just plug in calculator and you can see. So we will get 60 milliamps. So this is the total current is coming when you close this switch. So I will just write here for you that 60 milliamps is coming. Now, at this point, you need to understand is that this is 100 ohm resistor and this is 400 ohm resistor. Now, how this voltage can be equal to this one? So how much current has to pass through this one? How much current has to pass through this one? You see, this is 4 times greater resistance. It means current has to be 4 times smaller. So V100 has to be equal to V400. If this is 4 times greater, means current has to be 4 times smaller. So this is 4 times smaller, current has to be 4 times greater. So we can divide this one into 5 parts we can divide. So the each part, this is means in your head you can do, otherwise if you want to use formula. So the each part, if you divide into 5 parts, will be equal to 12 milliamps. So this has to be 4 times. So this has to be 48 milliamps and this one has to be 12 milliamps. So then this potential across this one will be equal to potential across this one. So then we have the same potential. But now again you have to divide. At this point again you have to divide. This current is coming to this junction, so means is coming to this point. So let me little bit clean this one so you can see now in a different way now here. So now until this point we have understood. Now 48 milliamps is coming here and this is 12 milliamps. Now this one you see is 300 and this one is 200. Now in here again we can divide into 5 parts. So here how much current has to pass in this branch? So this has to be about 36 milliamps. And this one has to be 24. You can do it. If you are not clear, just ask me. So this is how you will get. Okay. Now how much current will flow this way? So in this case you can see now current is higher, this is lower, it has to go this way, then it is balanced. So 48, 12 we already have here, this becomes 36, so it means 24 milliamps. 24 milliamps has to flow in this from left to right in this direction. So then you can come, you can see this is the best possible answer like this. Okay, please look at this one. Lot of steps. If you understood is wonderful. If you are not clear, just ask me. Maybe 1 or 2 more questions we will do and then that's all for today. Magnetism and thermal physics we will cover in next class. Okay, so can we go to next now? Yeah, if you have any question, just please type if you have questions. Okay, so Okay, so let's move to next one now. The similar type of question, little bit different. So that will also help you to understand RC circuit. So next question is also about this type of circuit. So let's try to do next one. Okay, here please. Now you can see actually here now same circuit, but we're gonna ask you question in a little different way. So first of all, read this question and try to answer by yourself. You see this question is about steady state, means after a long time. Steady state. So steady state, this is given to you now. So the steady state means that, so if you remember this point from our previous key point, so the steady point, when a capacitor has reached actually steady state, then capacitor acts like open circuit, means no current will flow through that branch of the capacitor. So I in that branch in which capacitor is connected will be 0. So we have to understand this point and then we need to answer this. So what this one is telling me, it's if I close this switch, for example, if I close this switch, it means current is coming from here. So the current is coming from here. It will split at this point into two parts. Current go this way and current go this way. Okay, so you can also see if current I is coming here, let's say this is I, it will also go through this one. Same current through this one, same through this one. And the same will be true for the second branch. This is also true. Same I will be the same through these two because they are connected in series and no current will flow this way. So using this argument actually, now let's try to figure out voltage. If, so you need to understand this resistance is 100, this is 300. So the voltage across this one has to be 1/4 of this one. Means you can divide this voltage into 4 parts. One part of the voltage is dropped across this one and 3 parts across this one. So from this information we can write down. So if we understand this point, so let me little clean this and write down for you. The voltage across this one then has to be equal to 3 volts. So this has to be 3 volt. So 3V. And the voltage across this one has to be 9 volt across this one. And this is double. So the voltage across this one means the delta V. If you attach voltmeter here, what you will see on the voltmeter, that will give you 8 volt. So this is straightforward. I hope this is not a problem. We can find out this one. Now, using this one, can I say that the voltage at this point, the potential at this point, that will be equal to 9 volts. And how about potential at this point? What is value of potential at this point? Potential at this point. So this is 9 volts. 8 volt drop. So it means this potential has to be 4 volt. So what is the voltage across this capacitor now? One side, excellent. It has to be C, excellent. So one side you can see is 9 volt, other is 4 volt. So we can see the voltage across capacitor, it has to be equal to 5 volts. So what we need to find, the question is asking you, we need to find the Q actually. Q, the charge on the capacitor. So we can QC we need to find. So we can say Q is equal to C times V. So the capacitance of the capacitor is given. So we have here. So this is 50 microfarad. So you have to multiply with 10 to minus 6 and the voltage is 5 volts. So if we solve this one, you will get this is 15 times 5. 75, so this is micro, so we will get micro coulombs. So this is over answer.